This is a video from section 1.2 in a linear algebra class. A matrix is in row echelon form, abbreviated REF, if it satisfies the following three conditions. Number one, if a row doesn't consist entirely of zeros, the first non-zero number in the row is 1. This is called a leading one. Number two, if there are any rows that consist entirely of zeros, they are grouped together at the bottom. Number three, in any two successive rows that do not consist entirely of zeros, the leading one in the lower row occurs farther to the right than the leading one in the higher row. Now let's take a look at some examples. Here are some examples of matrices that are in row echelon form. And so A is a 3 by 3 matrix where the first row is 1, 2, 0, the second row is 0, 1, 0, and the third row is 0, 0, 0. So you notice how the row of zeros occurs at the bottom of the matrix, right? That's condition 2. Now, I want you to take a look at the first row. Notice how the first entry in that row is 1, right? This is my leading one in the first row. In the second row, notice how this is my leading one. And you notice how the leading one in the second row is further to the right than the leading one in the first row. And so, therefore, this matrix is in row echelon form. If we take a look at part B, this matrix is 3 by 4, right? That's the size of the matrix. The first row is 1, 2, 3, 4. The second row is 0, 0, 1, 0. And the third row is 0, 0, 0, 1. Now, let's look at the first row. Notice how the first entry in the first row is a 1. That's my leading one. In the second row, the leading one is right here. And the third row, the leading one is right here. Now, we don't have any rows of zeros to worry about, and that's fine. It could still be in row echelon form. Now, notice how the leading one in the third row is further to the right than the leading one in the second row. And the leading one in the second row is further to the right than the leading one in the first row. And so, therefore, part B is in row echelon form. And if we look at C, notice how the row of zeros occur at the bottom of the matrix. And incidentally, this is a 4 by 3 matrix. That's the size of this matrix. Now, if we look at the first row, notice how this is my leading one. That's the very first entry in the first row. In the second row, this is my leading one. And in the third row, this is my leading one. And so you notice how the entry in the third row is further to the right than the entry in the second row. And I'm talking specifically about the leading one. So let me say that again. The leading one in the third row is further to the right than the leading one in the second row. And the leading one in the second row is further to the right of the leading one in the first row. And so this matrix, hence, is in row echelon form. Now, I'm going to say it this way. The following matrices are not in row echelon form. So let's go over that. Now, let's take a look at A. So now, here's the first row. I'm going to go 2, 1, 3, 4. The second row, 0, 1, 5, 6. The third row, 0, 0, 0, 0. The fourth row, 0, 0, 1, 0. Now, it just takes one condition to fail, right? Now, there's really two conditions that fail. Now, if we look at the row of zeros, the row of zeros are not at the bottom. That's enough, right? And this matrix is therefore not in row echelon form. And in the first row, two is not the first non-zero entry. And that's a problem, because in order to be in row echelon form, your first non-zero entry must be a 1, which we call the leading one. It's true for the second row, but just because it's true for the second row, that's not enough. It has to be true for the first row as well. Okay? So that's one example. Well, here's another example of a matrix not in row echelon form. And so we can have 2, 5, 7, 6, 0, 1, 0, 0. Now, this is not in row echelon form because the entry in the first row is a 2 and it's not a 1. The minute I change that number to a 1, this matrix would be in row echelon form. But because that entry was a 2, this matrix is not in row echelon form. And remember, it just takes one condition to fall apart. Now, I want to give you one last example. So what if I give you this one? 0, 1, 0, 0, 1, 0, 0, 0, and then 0, 0, 0, 1. Well, now, the leading ones are all good, right? So notice how in the first row, this is a leading one. In the second row, this is a leading one. And in the third row, here's my leading one. Now, if you go from row 3 to row 2, the leading one in the bottom row is to the right of the leading one in the second row. But the leading one in the second row is to the left of the leading one in the first row. So let me write that down. The leading one in the second row is to the left of the leading one in the first row. And so therefore we have a problem. And so C is not in row echelon form. Okay, that'll conclude this video. This is section 1.2 in a linear algebra class, and we went over the definition of what it means for a matrix to be in row echelon form and looked at some examples. Okay, thank you.